Hi everyone. Before we start our presentation, we would like to thank our Madam Natia for giving us this opportunity. Today we are going to do a presentation based on application of differentiation. Before we start, we would like to introduce our group. We are group 9 and also we would like to introduce our group members. First of all, myself, my name is Jivendra and my metric number is 01 AKM 21F1017. The second number is Muhammad Alfia and the metric number is 01 AKM 21F1026. And the third number is Yuvanathan and the metric number is 01 AKM 21F1030. And lastly, Arishkaj and the metric number is 01 AKM 21F1038. Before we start, I would like to introduce team roles and responsibility. First of all, introduction of group members and team roles and responsibility will be done by myself. And then introduction of differentiation will do by Uganathan. And then example of an application of differentiation of real life will do by Alpia. And solution for all questions will do by Naresh. And lastly, summary will do by Uganathan.
Introduction of differentiation. A gradient function is also known as its derivative. A function's rates of change is also referred to as the derivative. We can find rates of change by differentiation. It enables us to calculate the rate of change of velocity with respect to the time, for example, which is acceleration. It also allows us to calculate the rates of change of x in relation to y, which is the gradient of the curve on a graph of y against x. Isaac Newton 1643 and until 1727 and Gottfried Wilhelm Leibniz 1646 until 1716 who provide distinct and unified approaches to the differentiation and derivative. It's a crucial topic with numerous applications in everyday life. The derivative may inform you how fast you are driving or assist you in predicting stock market changes in machine learning. Derivatives are crucial for function optimization, generally attributed with the modern development of calculus.
Example of application differentiation in real life. First one is to calculate the profit and loss in business using graph. To check the temperature variation, to determine the speed or distance covered such as mile per hour, kilometer per hour. Derivatives are used to derive many equations in physics. In the study of seismology, like to find the range of magnitudes of the earthquake. By solving the application of derivative problem, the concept for this application will be understood in a better manner. Next. Application of differentiation. The differentiation is the subfield of calculus and there are various applications of differentiation in real world. The differentiation is very important part of maths as it is used in many scientific fields. Differentiation can be defined as the process of finding the derivative of the function. Differentiation can be used as a tool to calculate or study the rate of change of a quantity with respect to change in some other quantity. The most common example is calculation of velocity and acceleration. Velocity is given by v equal dx over dt, where x is the distance covered by a moving body in time. Similarly, acceleration can be given by dv over dt as acceleration is rate of change of velocity with respect to time.
We are going to find stationary points and their nature. We can solve this equation using the formula dy or dx equal to 0 or f prime x equal to 0. Stationary points are where graph changes direction. In this example, graph goes up, then then stops, then goes down and goes up again. When it goes up, the gradient is positive. When there is a stationary point, the gradient is 0 and the opposite. Now we are going to solve this equation. Y equal to x, y equal to 12x plus 1 to the power of 3 plus 6. So first we need to simplify this. When we simplify, we will get y equal to 12x to the power of 3 plus 36x square plus 36x plus 18. Then we need to differentiate this. dy over dx equals to 36x square plus 72x plus 36. Then we need to factorize, so 0 equal to 36x square plus 72x plus 36. We will get x equal to negative 1. Then we need to substitute this with this equation, so 12 times negative 1 plus 1 to the power of 3 plus 6. We will get 6. Therefore negative 1, 6. Then we need to differentiate the equation again. d2y over dx square equal to 72x plus 72. When x equal to 1, 72 times negative 1 plus 72. We will get 0. As I said just now, stationary point is 0. So we need to do the graph now. We just need to plot this. So negative 1 and 6. So the gradient is 0. Next, summary will be explained by Yuganathan.
The summary of differentiation is technique for determining a function of derivative. In mathematics, differentiation is the process of determining the instantaneous rate of change of a function depending on of its variables. We define derivative and seek to develop an intuitive understanding of their meaning. In the following chapters, we will see how to compute derivative and we will explore some of their many applications. The differentiation is something that will be incredibly valuable in every area of our daily life because it can be answer a lot of issues in mathematics. We should learn more about how differentiation is used in real life, particularly in fields such as astronomy, science, physics, business, and engineering, and others. Thank you.
Thank you, madam.
Thank you, madam.
Thank you, madam.